So these are some examples from day 25. On this example, they tell us that EFGH is a parallelogram, so find the measure of FG. FG is a side of a parallelogram. We learned from the notes that on a parallelogram, opposite sides are congruent. So if I want to find FG, so far all they tell me about FG is that its measure is 3z plus 8. Well, that 3z plus 8 would be equal to 5z minus 14. So minus 3z minus 3z. All the z's go to the right. So plus 14 plus 14. So I get 22 is equal to 2z. So divide by 2. And z is 11. But that doesn't mean that my answer is 11. It just means that z is 11. So now, if I want to know the distance from F to G, that would be 3 times 11 plus 8. I plug in the 11 in for z, and that's going to give me 33 plus 8, which is 41. ABCD is a parallelogram. Find the measure of angle B. So far we know about angle B is that its measure is 9x minus 5 degrees. But they also give me the measure of angle D, which these are opposite angles. And we know that opposite angles in a parallelogram are congruent. So 9x minus 5 would be equal to 10x minus 19 minus 9x minus 9x plus 19 plus 19. So cancel, cancel, and we get 14 is equal to x. So that's what x is, but we want to know what angle B is. So 9, measure of angle B is equal to 9 times 14. Is that minus 5? Minus 5. 9 times 14 is 126. Minus 5 is 121. A staircase handrail is made from congruent parallelograms. In parallelogram PQRS, PQ is 17.5. Let's label that 17.5. ST is 18. So this distance here is 18. And measure of QRS, which is up here, is 110. So this whole entire angle here is 110 degrees. So complete the explanation. The diagonals of a parallelogram, we learned this from the notes, they bisect each other. So QT is congruent to ST, and those are both going to be equal to 18. Same type of problem, but now they want to know the measure of PQR. So PQR. Well, if they tell me that QRS, which is this angle over here, is 110, these are consecutive angles, and consecutive angles in a parallelogram are supplementary. So the measure of angle PQR would be equal to 180 minus 110, which is going to give you 70 degrees. Complete the two-column proof. These are both parallelograms, so prove that angle G is congruent to angle L. Okay? So GHGN and JKLM are parallelograms. That was given to us. Angle G is congruent to angle HJN, which is the one over here. And KJM, which is the one over here, is congruent to angle L. And the reason for that is opposite angles of a parallelogram are congruent. HJN, which is one of the ones that are marked in blue, is congruent to JKM or KJM because those are vertical angles and those are congruent. The two blue angles in the middle are vertical. So then angle G is congruent to angle L through transitive property. Because if this is congruent to this and this is congruent to this, then they're all congruent. Transitive property of congruence. Determine whether this statement is always, sometimes, or never true, and then complete the explanation. If quadrilateral RSTU is a parallelogram, then RS is congruent to ST. Well, draw a diagram. Let's see. RSTU. So they're saying that RS and ST would have to be congruent. And that is going to be sometimes true. They could be congruent, but the only time they would be always congruent is if they were opposite. They're not opposite sides, they're consecutive sides. So this could be sometimes true. Opposite sides of a parallelogram are congruent, but consecutive sides may or may not be congruent. If they were congruent and it was a parallelogram, then it would make this a rhombus as well. Determine whether this is always, sometimes, or never true in a quadrilateral. No, if quadrilateral JHKJ is a parallelogram, then GH is congruent to JK. Draw a diagram. GH, JK. So they're saying GH and KJ. Those have to be always congruent because those are opposite sides. So this is always opposite sides are congruent. Determine whether it's always, sometimes, or never true in a parallelogram. ABCD. ABCD. Angle A is acute and angle C is obtuse. That can be never true because A and C are opposite of each other. So in this case, like I do have C being obtuse in the one that I happen to draw, and A is not. But these can be never true because opposite angles are congruent. So if they're going to be the same, they both have to either be obtuse or they both have to be acute. So this could be never true because opposite angles of a parallelogram are congruent. Angle A and angle C are opposite angles, so they must always have the same measure. Show that the quadrilateral is a parallelogram for the given values of the variables. Okay, so if these are going to be a parallelogram, then opposite sides would have to be congruent. So 6x plus 7 would have to equal 7x plus 2 minus 6x minus 2. So 6x, 2, 5 equals x. And then y plus 5 would have to equal 2y minus 3. So minus y plus 3 plus 3. Cancel, cancel. So 8 is equal to y. So now if I substitute this back, if I plug in the 5, really I can go for any x. I don't have to do it into both of them because they're going to be congruent regardless. So 6 times 5 plus 7 is 30 plus 7, which is 37. 37 is going to be JK, and it's going to be LM. 37, 37. Then for the other two, I can plug into whichever one I want. I'm going to prefer to use the y plus 5. So 8 plus 5 is just 13. So JK is equal to LM, and KL is equal to MJ, and it's a parallelogram since both pairs of opposite sides are congruent. Determine if the quadrilateral must be a parallelogram and complete the explanation. This figure has one pair of opposite sides that are parallel, and blank pair of opposite sides are congruent. A different pair. It's not the same pair. It's a different pair. So the conditions for a parallelogram are not met because it has to be both. They have to both be parallel and both be congruent. Okay, determine if the quadrilateral must be a parallelogram and complete the explanation. A 63-degree angle is blank to both the 117. Oh, that would have to be supplementary because 63 plus 117 is 180. This shows that both pairs of opposite sides are parallel by the converse of the same side interior angles. Because when you have a parallelogram with opposite sides being parallel, what happens in effect is that the consecutive angles make same side interior angles. They're inside of the polygon and they're on the same side. They're both the sides are acting as a transversal. So like the 63 and the 117 are both on the same side. Same thing with this 63 and 117. So the conditions for a parallelogram have been met. They are met.